This is part two for microchip. I'll go through the setup and then show you what part two is about. So basically, this is a challenge that I've got with the I2C on the Q24, and I'm going to show a very quick video on using software I2C. I explain. So I've got stuck at trying to get the I2C working on these particular chips. I'm going to go straight through this stuff. So basically, I have got exactly the same setup, no change. Okay, so VIO is the same, SDA is the same, they're all connected to the same port, but this time I'm going to be using software bit banging, essentially. I have got the same connections on RC6, RC5, RC4, and I've got the same pull-up, so I have changed nothing in the setup. I have power cycled, I've erased the chip, power cycled, and then I'm going to load in the software SPI. And what I'm looking for, because this is a slightly different screen, is this screen. I'm expecting to see 78 and 79 come back, and it will come back quite quickly because that's the way that it works. Okay. Stay in PowerPoint. So let's have a look at what's going on. Here's my code here. I'm going to compile exactly this code. So it's very similar. It's actually the same body in terms of the program, but it's just the setup slightly different because it's not using hardware I2C, and the only PPS I've got set now is the transmit for the serial. So if I come out to this is now compiling it using PICAX. PICAS, if I get out to the terminal quick enough, it's just programming it. Oh, there we go. It's already programmed it. It's quite fast. If I press the button, switch, sorry, there we go. Oh, it'll come up. Oh, look, it says on here 79. Oh, it's in a loop. There you go. It's in a loop. So it's found it. Same hardware, different results. So for me, this tells me that my hardware configuration is valid. I could put a GLCD on this and it will sort of work because I'm seeing the addresses, I'm seeing the right address, and I'm seeing the read address. So I'm very confident about that. Let's have a look what we're seeing on the protocol analyzer. Just wait for a, there we go, great. What we're seeing in here, we get a bank. We're getting a bank. Why are we getting a bank? Because inside of that bank, we're reading all 255 addresses, and then in banks of 16. So look, you can see 16 by 16 on the screen. If I pick the seventh one, I'm randomly going to pick this one here, and I'm just going to zoom in on it, and I happen to pick 7A. Well, I'm pretty close for a guess. 7A, I'm going to go to 7B, look. 7-8, sorry. So there's the 7-8. 7-8 goes, oh, not too fast. Oh, we can see we got the same shape pattern. Oh, interestingly, though, that the ninth bit doesn't follow by a stop. There is a gap. That's just a timing delay in the program or in the actual protocol that we're using. And there's the 0. Now, we are sending a 0 out in this particular case. I'll go into the source code, and I'm just going to change that 0 to, there's the device ID. Send that. Oh, there you go. There. 55. So I've just changed that to be 55 because that's the same as the hardware one. But as this is a demonstration program, I must remember to revert it. Start and make sure we see some action on the terminal because that will tell us things are working well. Oh, I disconnected it. I'm going to assume it's done it. Zoom out here in the protocol analyzer. It'd be the second bank here. Let me take that one there. Is that 78? 90. 9. That should be 7 here. What am I doing? 4-1. 0, 1, 2, 3, 4, 5, 6, 7 is this one here. 77's got a knack on it, which it would have. Then a 55, which is what I'm now sending. 78 ACK 55. And you can, there's a huge gap in here of 2 milliseconds. That's because we're printing stuff out on the screen. That's a huge gap there, but that's because we are printing stuff on the screen in between these bytes here. We're not doing that in the other hardware program because this is working. And you can see that we get back an acknowledge here from the device to say, yeah, there's something sitting on 78 as a write address, and there's something sitting on, it's accepted a byte here because it's acknowledged it. If we then look at 79, which happens to be the next one, which is the read address, we clock in a value of 41 NAC. Now, why is that? Even though we're just clocking the data in. It doesn't matter what the value coming back in. We've got the acknowledge from the 79 address. That's the target. That is goodness. Something on the oscilloscope. Let's have a look on the oscilloscope. We've got action on the oscilloscope. There we go. We got action on the oscilloscope. It may have disconnected over lunch. Oh, there we go. It had disconnected over lunch. And what we're getting is these are the pattern. That's the start signal when we picked it up the first time. And what we're seeing is in here, we're seeing good patterns of signals of starting and stopping. Lot. Are we getting any? Oh, there's a. Oh, we are so fast, look, on this oscilloscope. That's a packet of 8, look. Okay, so we're getting good signals in here. Now, I want to come back to this diagram. Question. Am I forced to use RC3 and RC4? Am I forced to use it? Because that's not been the case in the past. Let's recap pointer. I'm using these for I2C. Get rid of that. Am I forced to use these two? I just noticed that when I was going through the slides a moment ago. Says I2C SM bus compatible. Well, that wouldn't make any sense because that would make no sense at all. Because over in MP Lab 6.20 Q24 in my grid view, I can select. Oh, why did that jump up there? I'm not going to touch it. I can select anything though as the SCL though. I wonder if that's it. Please, Microchip, get on this and have a look, please. Thank you. Gets back to my PowerPoint. PowerPoint. Not that's another PowerPoint I'm working on. Gosh, a lot of PowerPoints open here. This is where I was on that particular slide. Oh, I don't know where I am in my PowerPoint. Oh, there it was there. So that's how I got it hooked up. So here we go. Question. Am I forced onto those two? But this video shows you how it works with software bit banging.